So in this video we'll be going through prime numbers and prime number decomposition, which is also known as writing numbers as product of their primes, and this will be done via drawing factor trees. So in this video we're going to talk about prime numbers and prime number decomposition, which is also known as when you get asked in a test or in a textbook to write a number as a product of their primes. So the first thing we need to establish is what is a prime number. Now there are many ways and many sort of errors in people's description of what a prime number is. Now prime number is a number that has two unique factors, and there are two key words that are there, one being the number 2 and the other being unique. So they've got to have two different factors. Now many people always seem to think that the smallest prime number is 1. However, 1 is only, although it's, if you have the common definition of a prime number as being a number that can only be divided by 1 in itself, then by that definition 1 is a prime number, because 1 can be divided by 1 and it can also be divided by itself, which is also 1. And however, 1 isn't prime. So if you remember the sort of definition that a prime number is a number that only has two unique factors, you won't make any errors. Now one thing to go on from there, and obviously a little reminder about what is a factor. So a factor is a number that divides into a number that leaves no remainder. Now there's a couple of things you need to know about prime numbers, is that there's only one even prime number. So 2 is the only even prime number. So all the other prime numbers are odd, but not all odd numbers are prime. So with regards to this, another thing that you also need to know is that prime numbers is a really important skill that you need to be able to know. So it's really important that regardless of from year 7 or age 11 all the way up to age 16, it's really important you at the very least know your prime numbers up to 50. Personally, if you get up to 100, that's probably what's expected, but at least up to 50 you should be fine. And I'd strongly recommend that you learn them just like you would a spelling test in English or learning spellings in a foreign language. So on the screen what you can see is all the prime numbers from 1 to 100 that you need to learn. And as I said, it's really important you get to know these prime numbers, and if you can recall them, excellent. And there are several things on YouTube, as well as obviously this video, that can help you learn these prime numbers.
All along, I'm a prime number, sat here on my own. Look at me, I'm a prime number, divisible by 1 and me. I'm a 2, I'm a 3, I'm a 5 and a 7. I'm 11, 13 and 17. Look at us, we are prime numbers. You can't make us by multiplying two smaller numbers. We are prime numbers, and maybe we're not all alone. I'm 19, 23, 29 and 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73 and 79, 83, 89 and finally 97. We're the prime numbers, prime numbers, prime numbers.
And if you're still awake and still with me, hopefully we can move on from that. So moving on from this, how can you tell if a bigger number is prime numbers, which is sometimes that gets asked in tests. So there are many ways of testing if a number is prime. Some are quite simple, some are a bit more complex with some crazy formulas for you to substitute numbers in. And performing these tests can be quite time consuming depending on the size of the number. So if you're testing to see if, I don't know, 1297 is a prime, it might take you a while because obviously that number is going into the thousands. One key thing is to remember that obviously, as mentioned, 2 is the only even prime number. So if you do end up with an even number that is not 2, then it's definitely not to be prime. So one way of testing to see if a prime number is, if a number is prime, is to divide the number by 2. It doesn't matter if it equals a decimal number, and then attempt to divide the testing number by all the prime numbers that are less than half it. Now if that makes absolutely no sense to you at all, do not worry, because I'm going to go through it. So going on for what we mean on this, so for example, 91 divided by 2 is 45.5. So what I'm going to do is I'm going to try and divide 91, because that's all my prime number, by all the prime numbers that are under 45. So if I just have my list of prime numbers, which is always handy to have, if you're like me, you've got a list of prime numbers that are easily accessible, might be worth, particularly if you're at a young age, maybe to have a little poster on your desk or on your wall with prime numbers, just any way of practicing your prime numbers, even having it as your wallpaper on your phone or on your tablet. Anything that you look at regularly would be great. So what we're going to do is we're going to divide 91 by each of, so all the prime numbers that are below 45, and just going to see which ones there are. So from this, if I start off, and what we're looking for is to see if there is a number where it fits in nicely. So we've got 91 divided by 2, 91 divided by 3, 91 divided by 5, 91 divided by 7, 91 divided by 11, 91 divided by 13, 91 divided by 17, 91 divided by 19, 91 divided by 23, 91 divided by 29, 91 divided by 31, 91 divided by 37, 91 divided by 41, 91 divided by 43. Now in terms of this, so this is one basic way of doing it. Now if you're familiar with roots, square roots, then generally speaking, although you can see here that we've got quite a lot of possible options that we're going to need to go through, but it is certainly one way of proving it, is to, rather than dividing by 2, if you go from all the prime numbers that are from 2 to the square root of 91. Now if you look at square numbers, the square number is probably, that's close to 91, is going to be 81 and 100. And square root of 81 is 9, square root of 100 is 10. So square root of 91 is going to be somewhere between 9 and 10. So really, the only ones I need to look out for are going to be these ones there. So if I then use my calculator and I work out, see if any 2, 3, 5, 7 are factors, then it's going to be it's not going to be prime. So 91 divided by 2 doesn't give me a whole number. 91 divided by 3 does not give me a prime number. 91 divided by 5 definitely doesn't. 91 divided by 7 doesn't. So therefore 91 is a prime number. So like I said, there are several ways of doing it. What I've just showed you is just 2 simple ways of doing it, depending on how much time you've got, but it certainly would get you marks in the exam. Now the next thing we move on to is prime number decomposition, so writing numbers as a product of their primes. Now writing numbers as a product of their primes, or POTP as I like to call it, is not the official name, just something that I tend to get tired of writing product of their primes, so just sort of abbreviate as POTP, is exactly what it means. So the word product is another word for multiplying, so product is just another fancy word for multiply of its prime. So basically what you are doing is you're wanting to create a multiplication calculation using prime numbers only. So for example, 120 as a POTP is 2 times 2 times 2 times 3 times 5, and again you can only use prime numbers only. So I couldn't have done 12 times 10 because 12's not prime, 10's not prime, so you've got to break those numbers up. Now another way of writing this is, as you can see, we've got the numbers written in numerical order going from smallest to largest, but it's also worth that when you have got sort of more than one set of numbers, we can write this using indices. So I can write this as 2 cubed, and it's 2 and I've got 3 of them, so the quantity comes as a power, times 3 times 5, and you can also write your answer like this. Now 200 as a POTP can be written as 2 times 2 times 5 times 5, which again could be written as 2 cubes times 5 squared, and there you go. Now if you have got a scientific calculator, and particularly one of the newer ones, you might find on your calculator, particularly the Casio calculators are quite common in schools, that you might have a button on the scientific section of your buttons that says fact. Now if you wanted to work out the POTP of any number, if you just on a Casio calculator, you want to look out for this particular feature. So the first thing you want to do is enter the number, press equals, and then press shift, and then this fact button. And what that will do is that will convert it into a POTP. Now commonly enough, that's obviously you can only use this if it's on a calculator question, or if it's on homework, that's fine, but generally speaking, these types of questions only really come up on a non-calculated paper, so make sure you know how to do this and what it means without the use of a calculator. Now breaking and going in the opposite direction of knowing the answer and trying to make up a question for it can be quite a challenging task. So as well as maybe potentially guessing some of these numbers, there is a fixed way of doing it as well. So if I can move down from here, so I cannot. There we go. So let's have a look at doing this. So an easy way of writing a product of its prime is by using what we call a factor tree. So again, and what I'm going to do is, the best way of doing this is to go through an example. Now what we've got is we've got 4,200 and we want to write this as a product of its prime. Now again, what's really handy with these questions is if you have your list of prime numbers either in your head or visibly seen close by. So the first thing you want to do is write down the number you want to find the POTP in a box so we can separate it. Now the next thing we then need to do is to find any two numbers, excluding the number used of 1, that multiply to give me 4,200. Now there are several different combinations you could have. So for example, I could have 42 times 100, I could have 420 times 10, I could go to any different combinations. Now it really doesn't matter which combination you go. If you think small, you'll end up doing more work. If you think big, you'll end up doing less work. However, thinking big can also mean that you've got more chance of going wrong. So what I'm going to go for 42 times 100. Now the next thing we want to do is, as you can see, I've got my little branch, is then think to yourself, okay, we've got 42, is that a prime number? And so looking at this, no, because 42 is in between 41 and 43, so 42 is not prime. So what I'm going to do is I'm going to do the steps again. So I want to again think of two numbers that multiply together to give me 42. So I'm going to go for 6 and 7. Now from this list, again, I check to see if any of those numbers are on the list. Yes, 7 is. So as 7 is a prime, I'm going to put a circle around it. Now for 6, again, as it's not prime, I'm going to think of two numbers that multiply together give me 6. And again, you can't use 1, so cannot use 1. Now the reason why you can't use 1 is because 1's not a prime number, and 2, it's completely and utterly pointless, because if I had 1 times 6, I'm then going to have to keep going on, and I could go on and I'll end up going on forever. So it's pretty pointless picking the number 1. Also, don't go decimal. So let's make a little note. Don't go decimal. So we don't want to have like going for halves and all this stuff, because again, it's making it more complicated than what it actually is. So anyway, going back to let's just pop up around that. So going back to the question, so here we go, I've got 3 times 2, and again both numbers are on the list, so I'm going to put a little circle around it. Once you've got a circle around a number, you leave it alone, that's it. So now I'm going to return to the 100, so again I'm going to go for 25 times 4. None of those two numbers are prime, so I'm going to go for 5 and 5, and those two numbers are prime. And for 4, I'm going to go for 2 and 2. Now, once you've got sort of circles around all the end of the branches, what we then need to do is write those numbers out. Now, generally speaking, if you can go through smallest to biggest, that will make your life a lot easier. So, for example, I could go 3 times 2 times 7 times 5 times 5 times 2 times 2. But a better way of doing it, or writing it, a more preferred way of doing it. Now, that is generally correct because the order in which you multiply numbers doesn't really make a difference, but it's very good practice for you to write them in numerical order. So what I'm going to do is I'm going to count how many 2's I've got. So I've got 1, 2, 3. So I've got 2 times 2 times 2. I've got 1, 3. I've got 2 5's, and I've got a 7. So that would be a much better way of writing it as a POTP. Next thing you may want to do is use the use of indices. So I've got 2 squared times 3 squared times 5 squared times 7. Again, to make sure you've got this correct, you might want to check on your calculator just for whole purposes, and you can go from there. Now, I've actually realised I've made a mistake there because I've only got 1 3, not 2. So let's just get rid of that, pretend that never happened, and we go from there. So again, by checking it, you can spot these silly mistakes, which is one I definitely did there, and I'm definitely going to leave that in because, like I said, it doesn't matter how clever you are, silly mistakes can be made, particularly if you're rushing it or your mind's not with it. So always double check your answers if you can. So moving on to another example, let's have a look. So this time we're going to go for 560, so thankfully a smaller number, and again I've got my prime numbers handy for me to do this. So again we're going to go for 560, so I'm going to put a little box around that. So again I could go for 7 different options. I could divide it by 2. I'm going to go for 56 times 10 just because I know it ends in a 0, it's a lot easier for me to do. So working with the 10, I've got 5 and 2, and both of those two are prime. With 56, I've got 7 and 8, and 7 is prime. 8, I've got 4 and 2. 2 is prime, and 2 and 2. Now, the difficult thing with regards to another error where people make is when they've got 8, they think they go for 4 and 4. So remember, it's 2 numbers that multiply to give you this top number, not add. So make sure you always remember that it's multiplying, and like I said, the clue is in what it's called product, and product means times. So once I've got this, all I then need to do is write down the numbers in numerical order, the ones I've circled. So I've got 2 times 2 times 2 times 2 times 2 times 5 times 7. And again, it's worth just double checking to make sure you've got the right answer. So here I'm going to have 2 to the power of, and again, I'll keep doing this. So it'd be 4 2's. So I've got 2 to the power of 4 times 5 times 7, and there is your final answer. And so again, writing your answer like this, all of this is going to be absolutely fine. Generally speaking, there is another topic that's linked with this, which is called lowest common multiple and highest common factor, in which you probably want to leave it in this form. However, if the question was just to leave your answer, or to write your answer as a product list of primes, then that would be the much preferred answer of what they would be expecting. Also, a question might ask you to use indices, in which you'll definitely want to go for this version here, because obviously it uses powers. So moving on to our last example, hopefully there is one. Yep, here we go. So we've got 2,250. So let's hopefully aim to not make a mistake on this one. So again, going to think simple. I don't need to go all challenging. I'm going to go for 225 times 10, in which I've got 5 and 2. Now, one thing you might want to do is, once you've circled a number, you might want to think, all right, let's just write it down. So for this, we're going to go for 25 times 9. 25 is 5 times 5. So once I've circled those, I'm going to write 5 times 5, and with 9, I've got 3 and 3. So looking at this, I've got 1, 2, so I've got 2. I've got 2 3s, so I've got 3 squared, and I've got 3 5's, and there is your final answer. And again, it's always worth double checking to make sure that you have got the right answer. In this case, I haven't made a mistake. We go from there. So hopefully this will kind of make sense on how you write numbers as product to their primes, but also just emphasising the fact that it's really, really important that you learn your prime numbers initially to going through this. Just like I said, just like you would learning spellings, learn your prime numbers and it'll make things a lot easier. Now, future topics that I'll link to this particular video is looking at lowest common multiples, which is known as LCM, and highest common factors, in which I'll do another video on each of those.